Another hello from West Virginia. Clearly, I have no idea where I am, but I think we're having fun with this. The other thing that we're having fun with is Joke of the Day, and I know that you love Joke of the Day. It is the best part of the day. So I know you're ready for this one. Which part of the eye is the most useful when you're trying to learn new information? The eye, which part of the eye is most useful when you're trying to learn new information? Well, the pupil. Because a pupil's a student. Students learn information. Okay, well, let's learn about complex conjugates. So we know how to add our complex numbers. We know how to subtract our complex numbers. We now know how to multiply our complex numbers. We're going to take a look at how to divide complex numbers. Being able to divide complex numbers requires the use of complex conjugates. So I've got a couple of complex conjugates sitting up here. I've got an a plus bi, that is a complex number. We've got our real part here, we've got our imaginary part here, we've got our mathematical model with the business in the front, the party in the back. We have another complex number right here. Once again, real part here, imaginary part here. The beauty of complex numbers that are conjugates, and before I get into that, let me point out that even though these two are complex numbers, they are conjugates of each other. What makes numbers conjugates, and this should be familiar because we looked at conjugates whenever we dealt with square roots. The beauty of conjugates, or step back again, I'm getting so excited. How you identify conjugates is you have the same two terms. The only difference is the sign that's between them. Notice I've got an A, I've got a BI. The only difference is this one has a plus, that one has a minus. That's what makes them conjugates. Now, what I was so excited about, the beauty of complex conjugates is what happens when you multiply them together. Take a look that I'm taking my A plus BI, I'm taking my A minus BI. They're sitting right up against each other. Right up against indicates what? Yes, multiplication. So I'm going to take these two complex numbers that happen to be complex conjugates, and I'm going to multiply them together. So we know that we're going to FOIL. We know that we're going to do the extended distributive property. We saw that before in the previous video where we multiplied our complex numbers. So that means I'm going to take A times A. Now A times A is going to be A squared. I'm going to take A times negative BI. Now positive times negative is negative, so I'll have a minus ABI. Now I've taken the first term, distributed it all the way through the second parentheses. It's the next guy's term. I'm going to distribute him through. So BI times A is going to be a positive ABI because BA, AB, it's all the same thing. And now I'm going to finish distributing him through, and a positive times a negative is negative. B times B is B squared, and I times I is I squared, and oh, there it is. Remember, I acts like a variable until you see I squared. When you see I squared, you should think -1. So what I have right here is a -1, and so therefore that means that when I multiply my b squared times a -1, and notice here it's a negative b squared times -1, that will end up as a positive b squared. Notice as well, these are going to cancel because I have a negative ABI and a positive ABI. They will cancel out. So I'm left with a squared plus b squared. But my point is this. What are you left with? There are no i's there. So therefore, whatever a squared is, whatever that number is, whatever b squared is, whatever that number is, I'm going to add those two numbers together and I'm going to get a real number. The product of complex conjugates is always going to be a real number. That is so helpful when you divide complex numbers. Because the whole point of dividing complex numbers, quite frankly, is to get the I out of the denominator. Very similar to the idea of square roots. Remember we said you cannot have a radical in the denominator? And I told you guys, I said, well, it happens, it shows up, so it's not necessarily illegal, it's just very bad form. And so to fix the form, we multiply the numerator and the denominator by the conjugate of the denominator. And that's exactly what we're going to do here. Similar idea. Because the I will show up in a denominator, it's not illegal, it's just very bad form. And so this bar right here always means division. So as a technicality, what's happening here is I'm taking my A plus BI and I'm dividing it by c plus di. In order to make that division happen, essentially I have to get the I out of the denominator. So what will happen is I will multiply the numerator, which is the top, and the denominator, which is the bottom. I will multiply them by the conjugate of that denominator. This denominator being a c plus di, remember conjugates have the same two terms, the only difference is the sign between them. So the conjugate for c plus di will be c minus di. So I will take this fraction right here, a plus bi over c plus di. I will multiply the numerator and the denominator by this conjugate, c minus di. Then at that point, notice what will happen is, when you multiply fractions, technically, you're supposed to cancel and those diagonals, cancel up and down, and then shoot straight across, but I can't cancel here, I can't cancel here, and if I cancel here, it just kicks me back to where I started. So I am just going to multiply across, and notice that when I multiply across here, I'm going to FOIL. And notice as well that when I multiply across here, once again, I'm going to FOIL. And when we FOIL, notice right down here, as we saw in this proof, when you multiply conjugates, you get the I out of there. And so the process of dividing complex numbers will be the process of getting the I out of the denominator. And in order to make that happen, you have to use the conjugate of the denominator. So let's take a look at some examples and give ourselves some practice in this. Notice that I'm going to divide each one of these and then I'm going to express it in standard form, the result in standard form. There's that mathematical model with the business in the front, the party in the back. We want the real part in the front. We want the imaginary part in the back. So I'm taking an 8 minus 2i, a complex number. I'm dividing it by 3 minus 5i, another complex number. In order to make this happen, I need to get that I out of the denominator. To make that happen, I need to multiply the numerator and the denominator by the conjugate of this denominator. Now remember, conjugates have the same two terms. The only difference is the sign that's between them. So I'm going to multiply my 3 minus 5i by 3 plus 5i. I'm going to do the very same thing up on that numerator. So I'm going to take this complex number 8 minus 2i and multiply it by this complex number 3 plus 5i. And remember, technically when you multiply fractions, you're supposed to cancel in the diagonals. Nothing's going to cancel there. Nothing's going to cancel there. Technically we should cancel up and down, but if we cancel these, we go back to where we started. So we're just going to shoot straight across. We're going to multiply across that numerator. And remember, that means we're going to FOIL. So 8 times 3 will be a 24. And 8 times 5i will be a 40i. Here, negative 2i times 3 will be a negative 6i. And in the back, a negative 2i times 5i will be a negative 10i squared. And there it is, I squared. What do you think? Right, negative 1. We'll take care of that here in just a minute. Let me clean this up. That's all scrunched up, and I know you're having a hard time seeing that. Let me clean it up for you. Plus 40i minus 6i. Here we go. Minus a 10i squared. That looks much better. All right, now in that denominator, we're going to FOIL again. 3 times 3 is 9. 3 times 5i will be a 15i. Inside, negative 5i times 3 is a minus 15i. And in the back, negative 5i times 5i, positive times negative is negative. Negative 25, here it is again, I squared. And when you see I squared, negative 1. So let me fix that up. I'm going to put a negative 1 in here and put a negative 1 in down here. So I end up with a 24 plus 40i minus 6i. And remember, if this is a negative 1, then I have a negative 10 times a negative 1. Negative 10 times negative 1 is positive 10. If I put a negative 1 down in here, then I have a negative 25 times negative 1, which is a positive 25. And notice here, 15i minus 15i cancel out. I only have a 9 plus 25 down in that denominator, which I was hoping would happen. Remember, I wanted to get rid of the I down there. That's why I used the conjugate. So now I'm going to add these two up. 9 plus 25 is 34. And on that numerator, I'm going to combine my real parts. 24 and 10 is 34 again. And my imaginary parts, 40i minus 6i, will be another 34i. Now, I can do cancellation. There's a couple of ways to cancel. I'll show you both ways. You settle into the way that works for you. One way is to say, okay, I'm going to separate up my real part, separate my imaginary part. And quite frankly, this is the best way to do it. Separate the real part, separate the imaginary part, because I want it to be in standard form. Therefore, I'm going to take this real part here, 34, and divide it by the denominator of 34. I'm going to take this imaginary part, 34i, and divide it by 34. And now I'm going to simplify those fractions. 34 divided by 34 is 1. 34 divided by 34 is 1 again, and I have a 1i. And you know you don't have to show a coefficient of 1. There it is, 1 plus I. The other way that you can do this is you can simply say, well, 34 divides into 34 one time. 34 divides into 34i, 1i times. The catch is that this 34 does need to divide into both of those. And if it won't divide into both, then you can't just go and divide it. That's why this method here is really the best method to separate out your real part, to separate out your imaginary part. Another way that you can go about it is you can say, okay, well, I'm going to factor my numerator. And I see that I can divide a 34 out of each term, leaving me with 1 plus I. And then what happens is the 34 out here will cancel with the 34 there, still leaving me with my 1 plus I. But again, your better bet is to just go ahead and separate out your real part, separate out your imaginary part, and simplify your two fractions. One thing I want to point out to you before I move on to the next example is when you multiply by conjugates, remember these two terms will definitely cancel. The terms that have the I in it, the imaginary parts, will definitely cancel. That's why we used a conjugate to get them to cancel. So if that's the case, a shortcut that you can take is you know the outsides and the insides will cancel. That's where you get your imaginary parts from. So the shortcut that you could take is you could say 3 times 3 is 9. Negative 5i times 5i will give you that negative 25i squared. So essentially you could just skip over this part. You would still need to know that I squared is a negative 1. You would still need to know that negative 25 times negative 1 is a positive 25. But then you could carry on from there. So again, that's a shortcut that you can take. If you recognize, oh, I'm multiplying conjugates, outsides and insides are going to cancel. And you don't have to worry about that because that will happen every single time you use a conjugate. Now, let's take a look at our last example here. So I'm taking this numerator and dividing it by this denominator, and I have complex numbers in the numerator and denominator, so I know I want to multiply by the conjugate of this denominator, but notice my numerator is a little bit complicated. So before I get into utilizing that conjugate, I think I'm going to simplify my numerator so that I can try to turn it into a simple complex number. So what I'm going to do first then is I'm going to multiply by that 5i and send that through, making life a little bit more simple for me. So 2 times 5i is going to be a 10i. Negative 3i times 5i, well, negative 3 times 5 is a negative 15, and I times I is an I squared. And, oh, there it is. I squared is what? Negative 1. So what I know is that I have a negative 1 sitting right here, and so that tells me that I have a 10i, and a negative 15 times negative 1 is going to be a positive 15. So now I have turned that big mess up on that numerator into a simple complex number. Now technically we're supposed to write it in standard form, but I think I'm going to save that for the last step. Even though this top number, the numerator, is not in standard form, it's okay because I'm going to end up multiplying by the conjugate. So things are going to get all messed up anyways. So at this point then, like I said, I'm going to take my numerator and my denominator and I'm going to multiply them by the conjugate of the denominator. This is where I want the I to get out. I'm okay with keeping an I up in the numerator, not a big deal. I don't want an I in the denominator. Again, very similar to radicals. So hopefully all these similarities are going to make life easy on you in terms of remembering what to do. So I'm going to multiply numerator and denominator by the conjugate of the denominator. Remember, conjugate has the same two terms. The only difference is the sign that's between them. So numerator and denominator by 2 minus 3i. So now I'm going to FOIL that denominator. And remember, I know my outsides and insides are going to cancel. So I'm going to skip over a little bit and I'm just going to multiply the front and the back. 2 times 2 will give me a 4. And 3i times negative 3i, well, positive 3 times negative 3 is a negative 9. And I times I is I squared. Whoop, there's that negative 1. Now I'm going to FOIL my numerator. 10i plus 15 times 2i minus 3i 10i times 2 is a 20i. 10i times negative 3i, well, 10 times negative 3 is a negative 30. And I times I is an I squared. Whoop, there's another one. That's a negative 1. And 15 times 2 will be 30. And 15 times negative 3i will be a negative 45i. So now I need to clean up all these I squareds. Negative 30 times negative 1 is a positive 30. So I have 20i plus 30 plus 30 minus 45i. And down here, a negative 9 times negative 1 is a positive 9. So I have 4 plus 9. And boy, I'm all over the place. I'm going to have to come up here now. I apologize for this mess. Okay, combine up like terms. 30 plus 30, the real parts. 30 plus 30 is 60. And 20i minus 45i will be a negative 25i. And in that denominator, 4 plus 9 is a 13. And like I said before, what I'm going to do at this point is I'm going to separate out my real part and my imaginary part and simplify those fractions. So my real part will be 60 over 13. Does that simplify? Is there a number that will go into both 60 and 13? No, there is not. I'm going to separate out my imaginary part. Let me scoot all this over. I am so very sorry. So 60 minus 25i over 13. Here we go. So we get our 60 over 13 minus 25 over 13i. And will 25 over 13 simplify? Is there a number that will go into both 25 and 13? No, there is not. So here it is, and it is in standard form. We do have the mathematical model with the business in the front and the party in the back. We've got our real part here and our imaginary part here. So it does not always cancel like it did in this one. Sometimes it'll be like this. Now let me give you one illustration, and let me erase a little bit here so you can see what I'm talking about. Let's say that once we did this problem, let's say instead of a 13 down here, let's say we got a 15. So we would have a 60 minus 25i over 15. Now remember, in this one I said since that 34 will divide into both, I'll divide it in here, cancel to be a 1, I'll divide in here, cancel to be a 1 as well. That doesn't always happen. Notice here if I separate out my real and my imaginary parts, I get 60 over 15. And here I get a minus 25 over 15i. When I go to simplify, notice what happens here. In each of these, 5 will go into each. 5 goes into 60 12 times. And 5 goes into 15 3 times. Actually, that simplifies out to be a 4. I'm so silly. Simplifies to be a 4. Here, 5 will go into each. 5 goes into 25 5 times. 5 goes into 15 3 times. And I really like showing you this because it illustrates that you will not always be able to cancel out completely on these and get whole numbers. That doesn't always happen. It happened here, but it did not happen here. So this is why I said the best thing that you can do for simplifying is to separate out your real part, separate out your imaginary part, and then simplify the fractions. And that's exactly what happened here. Separated out my real part, separated out my imaginary part. The fractions did not simplify, but they did in this case. So I hope that helps with the idea of being able to divide your complex numbers using those complex conjugates and the idea of what a complex conjugate is. Very, very helpful because complex conjugates, when you multiply them, they always cancel out the I. They always cancel out the imaginary part, and you can take a couple of complex numbers, turn it into a real number by multiplying by conjugates. I hope it helps. Have a great day.